All right. Example 3 has perpendicularly accelerating objects. So you're going to examine the diagram of the two masses connected by a strong taut string over a frictionless pulley, where mass 1 is 3.2 kilograms, mass 2 is 4.1 kilograms. The coefficient of static friction is 0.35, and the coefficient of kinetic friction is 0.28. So let's label what we know right now. We know that this is 3.2 kilograms. We know that this is 4.1 kilograms. We know on this first pulley that the force of gravity is going to pull it down. And we know that the force of tension is going to oppose it. We know on this one that the force of gravity is going to pull this down. And we know that the normal force is going to hold it up. Before I can label anything else here, I need to know if the masses will indeed accelerate. So for A, I need to know or show that the masses will accelerate. So or for A, if the force of tension is greater than the force of friction, then mass 2 will accelerate. Because I know my force of friction, if they do accelerate, they're going to accelerate this way. So my force of friction is going to be pulling this or opposing this motion. And then the force of tension would be working this way. I can also say this. M2 will only accelerate if M1 accelerates. So that means the force of gravity 1 has to be greater than the force of tension. If I put all of this together, if the force of gravity 1 is greater than the force of friction, because these two forces of tension are right here and they're equal. So if the force of gravity 1 is greater than the force of friction, then the masses will accelerate. We also know that the maximum force of friction is going to be caused by the coefficient of static friction, because static friction is always a little bit stronger than kinetic friction. All right, so I need to figure out what the force of gravity 1 is and the force of friction. I know the force of friction is equal to the coefficient of static friction plus or times the normal force. And the force of gravity 1 is equal to M1 times G. All right, so I can say my force of friction is equal to the coefficient of static friction was a given. It's 0.35. I don't know my normal force, but I can calculate my normal force because it opposes the force of gravity 2. So the force of gravity 2 is equivalent to mass 2 times gravity. Mass 2 is 4.1 kilograms. Gravity is 9.8 kilograms. So the force of gravity 2 is 40.18 newtons. So I'm going to plug that in right here. So the frictional force is going to come out to be 14.063 newtons. The force of gravity 1 is equivalent to the initial mass times gravity. So the force of gravity 1 is 31.36 newtons. Because the force of gravity 1 is higher than the force of friction 1, the masses will accelerate. So I said the force of gravity 1 is 31.36 newtons. The force of friction was 14.063 newtons. This is greater, therefore the masses will accelerate towards M1. Now I need to draw those free body diagrams. Because I need to determine the acceleration. So I'm going to move on to part B. For mass 1, it's 3.2 kilograms. I've got the force of gravity 1 pulling down, which is equal to M1G. So the force of gravity 1, like I figured out in the previous problem, is 31.36 newtons. The force of tension is pulling up on this, but I don't know what that force of tension is, so I'm going to have to leave that. I also know that I'm going to accelerate down, so this will be positive and this will be negative. For mass 2, I have a 4.1 kilogram object. I have the force of gravity pulling down on it, which is equal to the mass of the second object times gravity. So the force of gravity 2 is equal to 40.18 newtons. I have the normal force working up on this. And because we're not floating in the air, my normal force is equal to the force of gravity. So it's going to be 40.18 newtons. I already said we were accelerating this way, so I'm going to have the force of tension pulling my object towards mass 1, and I'm going to have the force of friction working against it. We're going to accelerate in this direction, so I have positive, positive, negative, negative. And because the objects are going to be accelerating, I need to remember to use the coefficient of kinetic friction, not static friction, to find frictional force. All right. Don't know frictional force here. It'd be nice to know. So I can say I guess I'll use a different color here for y'all. Frictional force is equal to the coefficient of kinetic friction times the normal force. My frictional force is equal to the coefficient of kinetic friction was given as 0.28 times my normal force, which is 40.18 newtons. So my frictional force is going to be 11.2504 newtons. So I can go ahead and plug this in to this diagram up here if I want to. So now I need to find accelerations. That's what B is really looking for. And to find acceleration, I'm going to set up those net formula problems. All right. So the forces acting on this first diagram or this first weight. So my net forces on the first one are equal to the force of tension plus the force of gravity. My net forces are mass 1 times acceleration. I'm going to break that down is equal to, I said the force of tension was negative. So I'm going to move it back here to the back to make my life a little easier. And the force of gravity 1 can be broken down into mass 1 gravity. All right. My net force for this second one over here is going to be equal to the force of friction plus the force of tension. I didn't include the force of gravity and the normal force because those are just going to cancel out. I can say my net force for this second one is equal to the mass of the second one times acceleration, or the mass of this second object times acceleration. And that's going to be equal to my frictional force, which is negative. So I'm going to move it to the back. Plus the force of tension, which is going to be positive, and I don't know that. I need to solve one of these two for force of tension. So I'm going to solve, this one has a negative force of tension, so let's make this one nice and pretty, right? Force of tension equals mass 1 gravity minus mass 1 acceleration. I can plug this into this now. So I have, or not there, sorry, I'm losing my mind. There. So I have mass 2 acceleration equals mass 1 gravity minus mass 1 acceleration minus the frictional force. You can solve all of this for acceleration and then plug it in and solve the problem, or you can plug in your numbers here. I think this is the second method that I'm about to do is the way that y'all prefer to do it. So mass 2 is 4.1 kilograms. We don't know acceleration. That's equal to mass 1 gravity. We know that's 31.36 newtons. I'm just going to keep the same color pen at this point. Minus mass 1 acceleration. We don't know acceleration, but mass 1 is 3.2 acceleration. Minus, we've got our frictional force here, which is 11.2504. I'm going to bring this 3.2 over, so I have 4.1 acceleration minus 3.2 acceleration is equal to 31.36 minus 11.2504. 4.1 minus 3.2 is 0.9 A equals 20.1096. All right, guys, sorry for my momentary lapse in math skills. This negative 3.2 becomes a positive 3.2 when you move it over. So 4.1 plus 3 plus 2 is not 3.2 is not 0.9a. It is 7.3a. So my a is going to be, or my acceleration is going to be 2.755 meters per second squared. The last thing the problem wants us to find is the force of tension in the string. So we're going to go back and use one of these formulas that solves for force of tension. So for C, I'm going to say the force of tension is equal to M1G minus M1A. The force of tension is equal to 31.36 newtons minus 3.2 kilograms times 2.8 meters per second squared. So my force of tension is going to be 11 point, My force of tension is going to be 22.54 newtons. All I have left to do for this is write my therefore statement. My therefore statement says, therefore, the masses will accelerate at 2.8 meters per second, down and to the left, respectively. The force of the tension in the string is 23 newtons. And you have solved all of example 3.